Hello again, and welcome to Bees on Main here in beautiful downtown Stoughton, Wisconsin, home of BroodMinder's global production facility. Today we're going to talk a little bit about swarms and the T2 and TH2 in particular. And with me is Theo Hartmann again, and also Rich Hogle, who is the engineer who's been responsible for crafting the SwarmMinder code, and has been with us a couple of years and is a good friend and also a beekeeper. So hello guys.
Hi Rich.
Hi Rich.
So Mr. Hogle, how are your bees?
The bees are doing fine, and just as a reminder to let folks know that I'm a new beekeeper. This is my second year, and due to some had a dead out this past winter after we had a long deep freeze where it didn't get above zero for almost a week, and unfortunately lost the hive, and just last week installed a nukes package, and I'm letting the bees settle in. They seem to be doing fine. They're very busy, and the trees are really starting to take off here, so they seem to be happy. So as a new beekeeper, I'm happy.
Well, that's great. Theo, we've got a great new Facebook page there, Beehive Monitoring. Encourage everyone to get onto that. Up at the top of that is a graph that looks pretty intriguing. I guess that's why you put it there. But it's got a bunch of red dots and squiggles. Can you tell us what's going on in that hive?
Sure, that's one of the hives I have in one of the outyards. It came through the winter real strong and was building up quite nicely. And the chart that you see there at the top has all these peaks. And to the history of the hive, it was split on April 11 because there was some signs that the hive may be swarming. And sure enough, about 10 days later, on April 21st, that's when the big weight drop can be seen in the middle of the chart. That's when the hive had the main swarm. Now, all these other peaks are temperature events caused by virgins. As you know, when you split a hive and remove the queen, the colony will raise one or multiple queens, and all these queens, they will emerge at some point. And every time a queen emerges, it creates some kind of a signature, temperature signature in the hive. And here we see two queens emerging prior to the swarm, then the main swarm, when one of the queens that came out takes off. Then we have two aftershocks, if you can call it that, and one aftershock the day after the swarm, and then an after swarm 2 days later. All of these events are real. This is what happens when queens emerge and run around, and they create havoc in the hive.
So Theo, you sound like you've known this all your life, but I recall that about a year ago we were pretty amazed at all the action that we saw in the temperature and these little swarms. How do you know what you're saying is true?
Well, it's you need to know BMath. That's one of the things that's really important in all of this. That it takes 3 days as an egg, 5 days as a larva, and 8 days as a pupa to develop a queen. And this is all hinges around that timing. And when you know what's going on in the hive, and if you have virgins or mated queens, you can go back and look at the events and then tie those temperature signatures or those temperature peaks to these things that happen in the hive. And it's really important for that reason that when people out there look at this, that they make some notes and take down the events that happen in the hive, because that has a tremendous influence.
So Rich, how did you make this happen?
Well, what we're doing for the SwarmMinder application is looking at recent temperature data, monitoring it for the past half hour, and we look at that and look for certain data signatures that show a a specific rise in temperature and then drop in temperature over a relatively short period of time. And when the right conditions are identified, we flag that information as a swarm, potential swarm, and store the data at a higher logging rate than is normally used, so that we can capture detailed information. And then that data is available for upload to my BroodMinder, where you as a user could take a look at it, and also if you've set it up, be informed that something's happening, something of interest is happening.
Are you happy with the way it's all working?
Absolutely.
Oh yeah, right.
Yeah, we're happy that with the implementation now, but of course, what we want to do is get more data, especially from users in the field who can help us reduce the number of false positives. We've made it very sensitive right now, as Theo said earlier, so that we capture all the events, but we do know that we're capturing more than just swarms and queen and virgin type events. And so we want to weed out the things that are noise and just get real data available that's helpful to the beekeeper.
Yeah, we know there's an awful lot of different hive configurations out there. And you know, like Theo said, BMath comes into play quite a bit. Theo, what if people are out there adding notes, Theo, what kind of info is the most valuable?
The most valuable is to know, did you split the hive? Was it a hive with a overwinter queen, a mated queen, or was it a hive that didn't have a queen and a virgin emerged? This is all important things. And then also, what we've seen last season is a large number of swarms and returns to the hive. So a swarm leaves and comes back. And so look at the rate chart very carefully, and you will be surprised how many of those swarms are actually not leaving the hive. They're leaving the hive, but they're coming back within anywhere from 1 to 4 hours. Now, Rich, I have another question for you.
Okay.
You have an interesting electronic beehive behind you. What is that?
Oh yeah, I meant to mention that in the intro. So this is our swarm simulator, and basically we've got some frames of honey and a couple of temperature controllers, one that holds it at around 90, 94, 95 degrees, and then another one that we can hit over the internet to create this pulse. And that was really crucial in trying to make all these software components play together. Rich's firmware is watching and sees this event and starts recording at 1 minute intervals. And then we want the cell or the hubs to alert people of what's going on. So we did a lot of testing with that and got it so that now what happens is once the device is triggered, it puts out a special signal. If a hub's around, it'll pass that immediately up to my BroodMinder, where my BroodMinder creates a cell message or an email alert, and it sends it to your phone. And as it happened with Theo last spring, he got out there and saw the swarm, and by the time he got the bucket, they were going back in the hive. So, I mean, that was just a beautiful example of our hives are doing this an awful lot more than we think. You know, we're not always there to watch, see what's going on. And I would say you learned a lot last spring, didn't you, Theo?
It did, yes, absolutely.
Yeah. So that's what we have going on. You know, we encourage everyone to help us. We see the data; it's all public domain, and that's great. But if you can point out these things to us, then it really helps figure out and take some good examples from the field. Anything you want to add, Theo?
Well, I think that's pretty much it. Thank you, Rich, and both Riches for that matter.
And Rich, what do you have to say for yourself?
No, thanks, guys, and certainly appreciate any feedback we get from beekeepers in the field, because it's very important to help us improve the algorithms.
Okay, well, thank you guys, and thanks for watching. And as always, every hive counts.